The jet wasn't built for this, yet it pulled it off anyway. The F-15X was just pushed into a test so extreme that analysts said it would fail, but what happened next changed everything. The roar that echoed across the test range didn't sound like a standard weapons trial. It was deeper, heavier, and unmistakably risky. The F-15EX Eagle II taxied onto the runway carrying something no other American fighter had ever carried at full scale, a mock-up of a hypersonic-class weapon, a new generation of air-launched payloads designed to exceed Mach 5. This wasn't just an experiment. This was a brutal compatibility test meant to answer a single question. Can the F-15X become America's hypersonic workhorse? Most aircraft never face a challenge like this. Integrating a hypersonic weapon onto a fighter jet isn't easy. These weapons are large, asymmetrical, and structurally punishing. They change aerodynamics instantly. They create drag and vibration patterns that even engineers hesitate to model. But the mission was simple. Strap the weapon on, push the aircraft to its limits, see if it survives. What happened over the next several hours would prove why the Pentagon refuses to retire the F-15 lineage, and why the X model may become one of the most important U.S. fighters of the next 2 decades. Hypersonic weapons are a different category of stress entirely. Carrying one is not like slinging a typical missile. For starters, size matters. A hypersonic glide vehicle or missile can be 15 to 20 feet long, with a weight approaching 6,000 pounds, and drag coefficients far outside the range of standard air-to-air or air-to-ground weapons. Even a mock-up punishes the aircraft. The Air Force calls this phase drag polar expansion. That term undersells what's happening. The aircraft is forced to fly with a massive aerodynamic anchor strapped underneath it, and the test team begins raising the speed, the altitude, and the aggressiveness of maneuvers step by step. Most fighters would lose stability. Some might lose structural integrity. But the F-15X isn't most fighters. It is a monster built on top of a monster, the final evolved form of the original F-15 airframe, modernized with new materials, new avionics, and new structural hardpoints rated for extreme stress. The hypersonic test was not just about the weapon. It was about proving the airframe itself could endure the torture. The test was divided into phases, each more dangerous than the last. Phase 1. Static load balancing. Engineers first measured how the weapon pulled on the mounting points. They simulated pressures the jet would face during Mach 2 turns, sudden climbs, and vertical acceleration. If the hardpoints had shown even 2 to 3% instability, the entire test would have ended. Instead, sensors showed the aircraft had remaining structural headroom even with the oversized weapon. This was the first sign the F-15X was built differently. Phase 2. High-speed taxi with hypersonic load. With the mock-up attached, the F-15X began high-speed taxi runs. This step looks simple, but it's one of the most dangerous. At speeds above 100 knots, an unbalanced load can create a sudden left-right yaw swing. If that happens with a hypersonic-class weapon, the fighter can shear its landing gear or slide off the runway. The F-15X remained stable. Its control surfaces compensated automatically. This confirmed that the redesigned flight computer and digital backbone were functioning as intended. Phase 3. Takeoff with hypersonic drag. Takeoff is where many aircraft fail hypersonic compatibility trials. The massive weapon disrupts airflow under the fuselage, creating a downward pull that tries to keep the jet on the runway. Engineers watched closely as the aircraft accelerated. And then, almost effortlessly, the Eagle II lifted. The audience watching the test knew this was the moment the aircraft crossed from theory into proof. The F-15X could take off cleanly even with one of the heaviest weapons ever mounted on a U.S. fighter. Phase 4. Supersonic stability test. Once airborne, the real danger began. Supersonic testing with hypersonic payloads is where aerodynamic chaos usually starts. Buffeting increases. The nose becomes overly sensitive. G-loads fluctuate, and shockwaves from the attached weapon can strike the fuselage. But as the F-15X pushed toward Mach 1.2, Mach 1.4, Mach 1.5, telemetry told a surprising story. The aircraft remained stable. The control laws compensated. The rigid twin-engine layout held firm. Even at high transonic speeds, the airframe resisted flutter, the deadly vibration that can destroy wings. This is where the test team realized the jet wasn't just surviving, it was outperforming predictions. Phase 6, high G maneuvers under extreme weight. To prove combat capability, the F-15X had to perform aggressive turns with the weapon attached. A hypersonic missile creates asymmetrical lift and drag, which makes turning extremely dangerous. But the F-15X dove into a high G demonstration run. 3G, 4G, 5G, and finally 6.5G. Not only did the jet hold the turn, but it also maintained precise control surface response. This is something few fourth-generation designs could do with a weapon of this size. Phase 6, simulated weapon release dynamics. This is the most brutal part of the entire test. When a hypersonic payload separates, it creates unpredictable turbulence. The test team simulated this release through vibration rigs and aerodynamic modeling during the flight. If the aircraft fails this simulation, a real release could cause a spin, strike the aircraft, or destabilize the wings. The F-15X passed every release simulation. By now, engineers and pilots were publicly stating what the Air Force already knew internally. The F-15X was becoming America's only fighter capable of operational hypersonic carriage without requiring total redesign. Why this test matters for U.S. air power? Reason number 1, hypersonics need a platform now. While fifth-generation fighters like the F-35 and F-22 struggle with internal base size and heat tolerance, the F-15EX is uniquely positioned. Massive payload, open hardpoints, high thrust, wide weapon separation distance. The U.S. needed a hypersonic carrier today, not in 2035. The X delivered exactly that. Reason number 2, the Eagle II extends American range. Hypersonic weapons allow a fighter to strike ships, hit hardened targets, destroy mobile missile launchers, or neutralize key command centers. And with its long range, the F-15EX can carry these weapons closer than any fighter except the B-21. This test proved that the Air Force now has a fast-reacting hypersonic striker ready for rapid deployment. Reason number 3, a 50-year-old design just outperformed next-gen fighters. This is the irony that military analysts love to debate. The F-15 design first flew in 1972, and yet, when upgraded, with digital flight controls, AESA radar, modern materials, the EPAWAS electronic warfare system, it can do something the F-22 and F-35 cannot currently do: carry and test hypersonic weapons at operational scale. This narrative reshapes how the Air Force plans for the next decade. Why the X is not going anywhere? The hypersonic integration test sealed the jet's future. Congress, the Pentagon, and the Air National Guard now have compelling evidence that the F-15EX fills a capability gap. Its structural strength is unmatched. Its payload capacity is irreplaceable. And its cost per flight hour is far below stealth platforms. The test didn't just prove performance, it proved longevity. The Air Force now expects the F-15EX to remain in service well into the 2040s, possibly the 2050s, outliving some fifth-generation jets built decades later. The message is clear: you don't retire a jet that just mastered hypersonic weapons. The F-15EX entered a test that should have exposed its limits. Instead, it revealed its strengths. It proved that a modernized fourth-generation aircraft can still redefine what a fighter jet is capable of, and do it in an era dominated by stealth technology. So, as the U.S. accelerates hypersonic development, one thing is certain: the F-15EX isn't stepping aside, it's leading the charge. If you enjoyed this breakdown, make sure to like the video, subscribe to the channel, and turn on notifications so you never miss the latest updates from the world of military aviation.